This video is about KNN, also called as K Nearest Neighbor. K Nearest Neighbor is the technique that is used to classify a categorical outcome or to estimate a continuous outcome. And the modus operandi of KNN is that it uses the most similar observations from a training or reference set, and we compare it against our query point to make a decision about that. And we measure the distance of our query point from our training or reference set using Euclidean distance. I'll be explaining this shortly. Here are some applications. The first application of KNN is image classification. Now, if you want to classify an image and you have some data that's called as a reference set, and that data has each picture has some pixels, and you want to classify a particular image, KNN will be used for that. So KNN will classify images by comparing the pixel values of an image to those of its k nearest neighbors in the training data. So it will see that the pixels of your image, they match very closely to which image in your training data set, and whatever is the nearest one, we will classify it accordingly. Then it's text classification, that's another application of KNN, whereby we classify documents such as news, articles, or emails by comparing the contents and structure of the text. Again, there will be two types of data. One is our query data, the one we want to classify, and another one will be reference set. The third one is anomaly detection, whereby we identify anomalies or outliers in data sets such as fraud detection or network intrusion detection. Another application of KNN is in imputing data. If some data is missing in your data set and you have to impute that missing value, but of course you don't know what was the missing value. So in that case, one of the best approach could be to use KNN to see what would be the most plausible value, the closest value that would fit there using KNN. And finally, about outlier detections, you want to identify outliers in data, and we use KNN. Now I will explain this process here. So let's say here is an example, and in this example we have this small data, and that data is about home loan applications where people they applied, and the bank has this data. So for instance, in this case, one of the critical variable is income. So this column is about income in thousand, and this column is about age. And bank has information whether those applicants, those who had applied for home loan, whether they defaulted or no. And as you can imagine, the background of this problem is that banks have rigorous risk management mechanisms. They want to identify those situations where a customer is more likely to default as a part of their risk management approach. Now, there can be different factors that would be contributing to whether a customer would default or not, but these two are important factors. And for the purpose of this exercise, we are using these two variables, that's income in thousand and age. And this is what happens to the default. Now again, in this data set we have two types. One thing is here, that's our reference or training data, which means this is the data that already exists with bank. And then here is data, the one in green color, that's a customer applies and their salary is 64,000 and age is 36 years, and you have to make a decision about this applicant based on KNN. In other words, your decision about this applicant, that the one with income 64,000 and age 36 years, would be based on what happened to the one with the closest one. So for instance, in this case, we do not have anyone with the same profile having 64,000 salary and 36 years age. So for this purpose, we will use KNN to find the closest points that are closest to this one. And this process starts with making a scatter plot, and for scatter plot, I will use these two variables. So select these two variables, income and age, and click on insert, and here's a scatter plot. Okay, this is a scatter plot, and of course we need to refine it. So one way to refine it, you can see here there is a lot of empty space here. So from here to here, this is all empty space, and also at the bottom this is too much empty space. So I want to get rid of this empty space. So let's start with this one. If I click on this one, on this x-axis, if I double click it, it says that the minimum is 0, which means that this axis is starting from 0. That's right. So what about if we start from 55? I mean, rather than starting from 0, what about if we start the graph from here, from this point? That's almost 55. So I will write here 55, that's a minimum, and hit enter. Okay, it seems like we can also start from 57 or maybe 58. So let's start from 57 because we don't have any data point here, and this is just empty space. So let me start this with 57. So I will enter here 57. Okay, and now the next part is also, you can see here there is a lot of space here at the bottom, and this is free space. We don't want that. So as a part of cleaning this graph, I would like to clean it. So I will double click on this one, and here you can see minimum, and minimum I would like to start from 30 because there are no data point below 30. So I can start this y-axis from 30, and clearly you can see here this is 30, and below 30 there is no data point. So we are safe to add here 30, and if I hit enter, so this is the one that we have. This is a little bit refined graph. Now this graph, it represents our reference set. Now the next step is to add our query point here. We also want to add these 2 points in green cells, and for this purpose I will click here, and I will use a function that's called as select data. So this is select data. Click on that, and here I will add here, and let me call it query point. So that's query data. And in query data, what's our x value? This is our x value, that's 64,000. So I will select this one. And what's the y value? Y value is this age, that is 36. So I will select this cell, and if I click OK, you can see this orange color dot, it appears here. That represents our query data point. Now a big part of KNN analysis is almost complete. Now what we have to do is that, this orange point in the graph, it represents this green data set, which means it represents our query point, and our objective is to see that these points, they match very closely to which data point. And if you see here, it looks like that this data point, it matches very closely with these three. And one thing that we have to do here upfront in the beginning is that we have to identify that what should be the value of k, which means we want to compare this data set against how many points. And it's critical that you define it upfront. You cannot change it later, because that would bring bias. So for instance, let's say in this case I'm using three neighbors that I want to compare my query data point against three closest neighbors. So for instance, it looks like that these three, they are the closest one, and all others, this one, they are far away. So if I look at these data point, whatever decision was made, I will make a decision accordingly. So for instance, I am curious to know what happened in this case, and we can see, let's say we can have a quick overview what happened in this case. So for instance, let's say this point, if we talk about this data point, so as you can see that this data point, in this case, the salary was 65,000. You can see here, salary is 65,000 here. So where is 65,000? So this is 65,000. So this is 65,000. And in that case, did customer default? Yes, customer defaulted. So it means that this data point, it represents where customer defaulted. So that will be yes. Okay, now let's look at this one. Now this one, it roughly represents income of 64,000 and age of 38. So income will be roughly 64,000 because this is 63,000, this is 65,000, and because it is somewhere in between, so I would imagine it's something close to 64,000, and age will be 38. Okay, so 68, so this is the one. So 64,000 is salary and age is 38, and in this case decision was no, that the customer did not default. Okay, now let's look at this one. What happened to this one? Now this one, as you can see, that here salary is 63,000 and age is 34. Where is that point? 63,000 salary and 34 being age. This one. So looks like this is the one. 63,000 is the salary and 34 is the age, and again in this case the customer did not default. So again in this case, customer did not default. Now we have to make a decision about this orange point, and as we decided upfront that we will compare our point against three closest neighbors, and it looks like in two cases customers did not default, but in one case customer defaulted, so which means that the chance is 1 out of 3. So we have 3 points, and the probability that the customer will default is 1 out of 3 or 33%. And then you will make a decision accordingly. You will make a decide about a cutoff point. So for instance, a cutoff point could be 50%. You say, okay, if 50% is the probability, then we will not give a loan, but if it's less than 50%, then we will give a loan. Okay, so this is a visual idea of how we do KNN and how we make a decision. So again, in this case, our decision would be the probability that the person would default is 33%, and looks like it's a low probability. If your cutoff point is 50%, then maybe you can give them loan. But we have to do it more systematically and more objectively. So let's do it that way. Okay, let me remove this one. In the next one, we will calculate Euclidean distance. So Euclidean distance is an alternative to when we were calculating here distance, we were saying that okay, this point appears to be very close. So this Euclidean distance is more objective, which means that we want to measure the distance of these points against each of these sets. And for this one, we will use this formula. The formula has been given here. and which means square root is equal to square root and q1 means query point. So this is our query point at 64,000 minus r1, that's a reference set, and then we take it square, and then plus q2, this is q2, that's age 36, and then minus r2, this is r2, and then again we take it square. So it will be square root and this point 64, and we need to make sure that it is locked, because in the next step I will be dragging it down. So if you are using MacBook, you can press Command T, or if you are using Windows, you can use Fn and F4 keys together, and that will serve the function minus this 65, and then I will take it square, and then next thing is plus this point, and again make sure this is locked. So again you can either press Command T if you are using MacBook, or you can press Fn and F4 key irrespective of you are using Windows or MacBook, and then minus this one. And please note that only these are locked, they are not locked, only our query points are locked, and then close the parenthesis, and then it gives us this Euclidean distance is 1.41. So more specifically it means that, for instance, if I highlight these cells, I would say that the distance between this query point in green color and these data points in yellow color, the distance between them is 1.41. That's a straight distance, Euclidean distance. Okay. In the next step, I will drag it down, and that gives us the distance of each point, the distance of our query data against each of these reference data points. And in the next step we are going to rank it, which means we want to see that which one is closest and which one is farthest. So I will use a ranking function, and that's called as rank, and I say rank this one, which means 1.41 against this data set, and again make sure it's locked by pressing Fn F4 key together. And then the next thing is that it says how do you want to order it. I mean, do you want to order it in ascending or descending order? So for instance, you can see here it appears that 0 for descending and 1 for ascending. Now pause this video for a moment and think about which option should I use. Should I use descending option or ascending option? If I use descending option, which means the point with the furthest distance, it will be at the top, and then it will be decreasing gradually. And ascending means that the smallest value will appear at the top, and then it will be increasing gradually. So what do you think? Which option should I use? Now we should use this ascending option, which means that increasing gradually, and the reason is that because we want the lowest value to appear here, and because that in KNN we are looking for the nearest neighbor where the distance will be smallest. So therefore we want those data points that are closest, which have the lowest distance, they should be here. So that's why I use ascending, which means the lowest value, the lowest distance, it will be represented here, and then if I drag it, so that gives us this ranking. Okay, now in the next one, let me drag this one here, and in the next one we are going to use VLOOKUP function to make a more structured decision making. So for this purpose I have copied these two columns, so this rank column and this default column. So I copied these two columns, and I pasted them here, and this is k, that's 1 2 3, which means I want to compare them against three neighbors, and no formula has been applied here, only copy pasted these two columns, rank and default. And one thing that's critical to note here, that as you can see here default appears first and rank appears later, but in this column rank appears first and default appears later. And this is because I am going to use here VLOOKUP function, and in VLOOKUP function we have to use this format. So I will explain it. Let's say I enter here VLOOKUP, and in VLOOKUP I say lookup for this one, that's 1 in this table, and again I will lock it by pressing Fn and F4, and I want it to pull the result from the second column. And this is the reason that why this default appears here as the second column. I mean, one possible option could have been that the default column comes first and rank comes later, but in that case VLOOKUP does not work. So because in VLOOKUP I want my results to be pulled out from this column, this is the second column, I mean second column, I'm talking about this table. So within this table, this is the second column, that is whether the person defaulted or not defaulted, and I want my results to be pulled from this column, therefore it should be column number 2. If it's at number 1, VLOOKUP may not work. And the last thing is that VLOOKUP will ask that, okay, do you want exact matches, or is it also okay if I bring something very close? So we say false, which mean, as you can see here, false, which mean exact matches. The true option represents approximate matches. We don't want approximate matches, we want exact matches, and as you can see here, exact match is represented by false. So I will write here false and hit enter. And before I hit enter again, very quickly, this is VLOOKUP function, and VLOOKUP I say lookup for this one, that's number 1, and then comma in this table, in this whole table, and these two columns, they will be locked, and I want my results to be pulled out from the second column, therefore I write here second 2 and then false, which means I want exact matches. And if I hit enter, it gives me yes, which means that in this case the closest the first closest neighbor, the decision was or the customer defaulted. Okay, and if I drag it down, and I will drag it down only to 3 because my k value is 3, I'm comparing only against 3. So you can see here it's exactly the same thing that we found earlier through the visual part, that there was a probability of 1 out of 3, which means 1 had defaulted and 2 did not default, which means the probability that this person, the person that has been represented by green color data, so the probability that they would default is 1 out of 3, and that is 33%. Again, we will compare it against our cutoff point. So for example, let's say if your cutoff point is 50%, then you could say, okay, 33% is less than our cutoff point, so maybe the home loan application of this person can be approved. So in this way, KNN is a very useful technique for decision making.